C'è l'audio, Lorenzo.
Olá, boa tarde, você está nos assistindo. Começamos agora o 4º webinar internacional da ABREN, Biogás e Biometano. Ele será transmitido apenas em inglês, dado o evento ser internacional e os palestrantes. Agradeço imensamente a presença de todos que estão aqui conosco e vamos começar. Welcome to the 4th ABREN International Webinar, Biogas and Biomethan. That event that we have some specialists from Italy, Morocco, and Brazil to talk about this important source of energy and to the society. Biogas generated from anaerobic digestion of organic waste, mainly from poultry, pigs, cattle, slaughterhouse, and dairy waste, urban and vegetable waste, reduces the greenhouse gas emissions generated by the methane from this waste by 80%. It's estimated that Brazil could replace 40% of diesel with biogas, and only in the urban fraction of organic products would it be possible to supply 100% of garbage trucks and 90% of urban buses with biomethane extracted from biogas through purification process. According to the Road Biogas Association, Brazil uses only 2% of this potential. And to talk about this huge potential, I will ask to participate Ph.D Lorenzo Maggioni. He's a PhD from the Faculty of Agriculture of Milan. He's an expert in the biogas and biomethane sector. Since 2011, he's the head of research and development of Consortium Italian Biogas. He has participated and is participating in 10 projects funded by the European Commission. And he was a speaker in numerous international conferences and workshops. And Lorenzo Maggioni participated in an event in Brazil last year in talk about the European and Italian biogas and biomethane market. Thank you, Lorenzo. He'll talk about perspective of the European and Italian biogas and biomethane market. Please, Lorenzo, have the word.
Thank you very much, Yuri. Thank you. First of all, thank you for your nice invitation. It's a pleasure to be here with you, even if only in a virtual way. Last year was really better to be in Brasilia, and I hope it will be soon possible to do it again. Now I'm starting to share my presentation. Now, okay, I think it's working. So just a few words about the Italian Biogas Consortium. Our is an association that brings together more or less 740 farmers that have already built a biogas plant, together with 200 companies coming from all over Europe and sometimes also from all over the world that propose technologies and services linked to the biogas and biomethane production. The Italian Biogas Consortium is really active at a national level, but also at a European level. We are the founder of the European Biogas Association. We are participating in several research projects funded by the European Commission. We are also active in a very important project linked to the production of biomethane. The name of this project is Gas for Climate, and in this project you can find all the most important companies that transport the natural gas from foreign countries. And the aim of this project is to demonstrate that it's possible to produce a very high percentage of renewable gas, in other words, or of renewable hydrogen and renewable biomethane, and to inject it into the natural gas grid. First of all, I want to to give you some numbers about biogas and biomethane in Europe. And after, I will focus my presentation on the situation we have in Italy. In Europe, at the end of 2018, we had more than 18,000 biogas plants with an electric installed power more than 11,000 gigawatt. The total production in 2018 was 73,500 gigawatt hour. In order to produce this huge amount of renewable electricity, we use agricultural residues, and around the 70% of the total production of biogas is made thanks to this feedstock, agricultural residues and energy crops. The second most used feedstock is the organic fraction of a municipal solid waste. In this slide, you can see the biomethane market. The numbers are really smaller compared with the one of biogas, but the market is increasing. During 2019 and 2020, I don't want to say we are doubling this number, but we have in Europe a really big increase thanks to Italy and to France. At the end of 2018, in Europe, we had 610 biomethane plants with a total production around 2 billion cubic meters per year of biomethane. For biomethane production, exactly as it is happening for electric energy production, we are using most of all agricultural residues. In this case, is forbidden, is not possible to use energy crops. In order to produce biomethane in Europe, you need to use only agricultural residues, agricultural byproducts. It is also possible to use the organic fraction of municipal solid waste. The more than 70% of the total amount of biomethane is produced thanks to agricultural byproducts. Talking about technologies, on the right of my slide, you can see the different technology that is possible to upgrade the raw biogas into biomethane. In the past, we used water scrubber. Now, in the last 3-4 years, we are increasing the use of membrane. In Italy, after I will show a slide regarding Italian market, I will explain which is the most used technology in the existent biomethane plant. But okay, I don't want to say one technology is better compared to other. All the technology allow you to reach the technical standard, the technical quality standard for the injection of biomethane into the natural gas grid, or for the direct use of biomethane in the transport sector. So for the moment, we have not a best technology. It's possible to use all the best technology to produce biomethane. Now I want to start to talk about biogas and biomethane in Italy. Italy is the second market after Germany. We invested a lot of money, more than 4 billion euro in the last 6 years. We have more than 1,800 biogas plants with a total installed electric power more than 1,300 megawatt. It's an equivalent of 3 billion cubic meters of biomethane per year. Thanks to the biogas sector, we created also, it's important to stress that we created also a lot of green jobs. We estimate around 12,000 green jobs. Talking about biomethane, now I want to explain what is happening in our country. For the moment, in Italy, we have not more subsidies for the production of electricity. In September, and only for a few months, we will have the opportunity to submit new projects, around 100 of new projects. We are waiting for a new decree that will allow us to start again with renewable electricity production thanks to biogas. So in September, we will have the opportunity to build only small plants with a maximum size of 300 kilowatts and only fed by manure from cows, from pigs, and from other animals, adding a small quantity of other byproducts. But the total amount of this new biogas plants will be very, very, very small. The most interesting market for the moment in Italy is the biomethane market, and now I want to explain why. Every year in Italy, we have a consumption around of 1 billion cubic meter of natural gas used in the transport sector. In Italy, we have a fleet of natural gas vehicle, more than 1 million cars. We have 3,000 LNG trucks, and we are building a large number of filling stations, compressed natural gas filling station, and also liquefied natural gas filling station. We have around 1,360 CNG filling station and 71 LNG filling station. But 20 new LNG or CNG station are in the process of authorization. So what about biomethane? In March 2018, our Italian government published a really interesting law that introduced subsidies for the production of biomethane. The maximum biomethane production with subsidies will be 1.1 billion cubic meter per year. And it's important to stress that in order to achieve these subsidies, you have to demonstrate that the total amount of biomethane you produce is used in the transport sector. How is possible? You can show it injecting biomethane into the natural gas grid, and after, thanks to a mass balance process, it's possible to transport in a virtual way the biomethane all over Italy and to sell in the existing CNG filling station. It's possible to compress the biomethane and to transport it by trucks and to sell it in filling station, or it's possible to liquefy the biomethane and to sell in the LNG filling station. The Italian government give you really interesting subsidies in case you build a new filling station. You receive 0.6 million euro for each new filling station you build, and you receive 1.2 million euro for each liquefaction unit you build. These two different subsidies is possible to add together these subsidies. So in case you build a new filling station and a new liquefaction unit, you receive 1.8 million euro. And in addition, you will receive also the subsidies for the biomethane production. And this slide is possible to see which kind of subsidies you receive. Now I don't want to explain how the system works. Last year when I was in Brasilia, I have explained it, and now I have not enough time. It's really a little complex, our Italian system, but I just want to explain using numbers. So in case you build, I just want to give you an example, 1 megawatt equivalent, electric equivalent biogas plant. So it means 500 cubic meter of raw biogas and more or less 250, 280 cubic meter per hour of biomethane, your turnover will be around 1.3, 1.4 million euro of subsidies. In addition to the subsidies, you receive also the you have to sell your gas, your biomethane, or the liquefied biomethane, and you receive money thanks to the selling. So now I just wrote some examples. In case the price of natural gas is 0.18 euro per cubic meter, you receive 400,000 euro per year more. In case you sell your biomethane directly to the final customer thanks to a filling station with an average price of 0.55 euro per cubic meter in the filling station, you receive 1.2 million euro per year. So the total amount, the total turnover per year will be a minimum of 1.7, 1.8 million euro to a maximum of 2.5 million euro in case you sell directly to the final customer your production. And it sounds really, really interesting. And remember that this example is linked to a plant with the size of 1 megawatt equivalent. But in the next slide, you will see the average size is really bigger in our country. In this slide, you can see the list of existing biomethane plants. For the moment, we have 18 biomethane plants with a production around 150 million cubic meter per year. At the end of 2022, we will double the production, so we will reach a production of 300 million cubic meter per year. As you can see, the size is very large. The smallest plant is a plant built close to Milan using sewage. Is a plant with a size of 120 cubic meter per hour. The biggest plant is a plant with a size of 3,750 cubic meter per hour, but really they are doubling the capacity. And I think Mr. Moretti
is already doubled.
Yes, I think Mr. Moretti will explain something more because his company built this upgrading plant. Also, other plants have a very large site. There are other plants with 2,000, 3,000 cubic meter per hour, and we have, unfortunately, for the moment, only 2 plants fed by agricultural byproducts. One based in Emilia-Romagna region is a company named Caviro, that is the largest Italian producer of wine. So they have a 2,000 cubic meter per hour plant, and another plant is based in Lombardy region with a size around 600 cubic meter per hour. It's really important to stress also that in some of these plants, they are not only producing biomethane, but they are also producing carbon dioxide. In the largest plant in Montello, they are producing a very large amount, a very huge amount of biomethane. But Mr. Moretti will explain better. This is the same, the map of exactly the same plants, but here you can see where they are located. And in this slide, you can see the liquefaction plant that we are building. In Italy, we have 20 projects. All over Europe, we have only 5 bio-LNG plants. In Italy, in the next 2-3 years, we will build at least 20 projects. Starting from a size of 4 tons per day, it means 1 megawatt electric equivalent, a little less really, to a maximum size around 20 tons per day. Now I have the last 4 or 5 slides. One case study. Cooperativa Speranza is agricultural, is 5 farmers that are working together. So it's a cooperative. They own 2 existing biogas plants, each one with the size of 1 megawatt electric. They are starting to produce the first Italian kilogram of bio LNG. They will use 100% agricultural byproducts. They will produce 5.5 tons per day of bio LNG. It's interesting to show also that they are producing a lot of heat and they are selling the heat to a cancer research institute. So in this, using the heat coming from the biogas plant, the research institute spend less money and create less pollution, air pollution. How they will use the bioenergy? They signed an agreement with a company whose name is Maganetti. Maganetti SPA is the owner of a large fleet of trucks. They have already bought 42 LNG trucks. So Maganetti company will start to use 100% of bio LNG in their LNG heavy trucks fleet. The Maganetti company owns one LNG filling station, but together with the Cooperativa Speranza, they are building a second one close to Milan, in the south of Milan. In the next 2 slides, I will explain why they decided to use LNG and not more diesel. Using LNG is possible to save money, around 5,000 euros per each truck every year, and it's possible to decrease the pollution. First of all, in case you use fossil LNG, you decrease the 15% of emission of carbon dioxide into atmosphere. When they will start to use bio-LNG, the percentage will increase a lot. It will be possible to demonstrate that you have a decrease more than 90%. Using LNG or bio-LNG is possible also to decrease a lot the quantity of NOx in the atmosphere, less than 70%, and of particulate matter, less than 99%. Also, the noise of the truck decreases a lot, less 6 decibels for each vehicle. This is the alarm that is saying that I have to stop my presentation. Sorry, but I have the last slide. This is the perspective in Italy. We are sure that in the next 2-3 years we will reach the goal of 1.1 million of cubic meter of biomethane, and the half of the total amount of biomethane we will produce will be advanced biomethane. Advanced means that we will use only agricultural byproducts, we will use only organic fraction of municipal solid waste, and we will not use energy crops in order to produce this huge amount of biomethane. So we will be able to produce at least 550 million per year of advanced biomethane and the same quantity of biomethane. So this was my last slide. Thank you for your attention, and obviously at the end of the presentation I will answer your question. Thank you again, Yuri.
Thank you, Lorenzo. This is excellent presentation again to our Brazilian market of biogas and biomethane. And the next, Ugo Moretti, Master of Science in Chemical Engineer at the Polytechnic of Milan. In 1987, he founded the Techno Project Industriale. He has a large experience in energy savings related to plant servers in construction and application in the chemical and food industry of equipment and plants for the production of carbon dioxide and purification and treatment of technical gases. In 1997, he established the company TPI in São Paulo. Today is TPI Brazil. Ugo Moretti will talk about upgrading of biogas into biomethane and CO2 capture. Please, Hugo,
Yes.
have the. I will share your screen now.
You have to you have to share my presentation because I cannot. Okay. Now, our company is a company not coming from biogas field, but from but is a gas company specialized since 40 years in purification and production of CO2 and the separation of CO2 from any kind of mixture, including, of course, biogas in the last years. Therefore, we don't start from technology as the other, let's say, colleagues, from technology of biogas, but from technology of gas treatment. We are also belonging to a company which is a major producer of gas, which is in Italy. Therefore, we provide also to use this company for testing also our technology on CO2, of course, and application of CO2. Now, even if our experience in CO2 extraction is mostly based on traditional solvent, which is amine, for instance, or hot potassium carbonate, we decided to pass to the membrane mainly and to, of course, still amine, after having selected all the technologies for gas and separation and gas purification. We know PSA for our hydrogen plant, for oxygen plant, for nitrogen plant, as well as membrane that we used since ever for nitrogen production. Therefore, looking at all the technologies, we really decided to choose only two technologies, even if also, as Lorenzo told, all the other technology are performing in sufficient way to produce biomethane according to the request of SNAM or the gas or the distributors of gas. Nevertheless, looking at the PSA, we decided not to use because we think that for a certain reason that off gas and is too rich in methane, we believe, and is not possible to recover CO2. Same story for washing water, is not possible to recover CO2, while PSA is better for application in landfill because our system is not able to separate methane from nitrogen. Therefore, PSA is better for such application. At the end, looking at the last technology, which is membrane. When we start, membrane were still not very tested on biogas. But anyway, we start with the 2 years test in Montello plant, which is actually the largest. And we deal with the Evonik company with the 3-stage system. And we choose as a main technology, membrane system based on 3 stages. This is because allows us to recover CO2 as we did, and in most of the plant, the largest plant that we have in organic waste biogas, which is the most difficult for the impurities anyway, we have installed the largest plant based on that system in Montello that are actually producing 4,500 cubic meter per hour of biomethane, actually. And as last week has been started the first of the next 3 lines up to a total amount equivalent to the actual one. Therefore, within a couple of weeks, it will produce 9,000 cubic meter per hour of biomethane and more or less 10 tons per hour of CO2. CO2, food grade. Actually is producing, the actual plant has produced in the last 2 years 40,000 tons per year of food grade CO2. That has solved the problem of lack of CO2 in Italy and also in all of Europe in the last 2 years, that there was a lack of CO2. Last year, 2 breweries in England has been closed because there was no CO2 on the market. It's incredible. But therefore, now is one of the main sources. Then, therefore, we have the advantage, let me say, to use our CO2 recovery plant also to recover the last methane contained in the off gas. Normally in the membrane system, 3-stage membrane system has the advantage that you can regulate the percentage of CO2 in the methane to be injected in the grid or to be sent to the LNG or to CNG. Therefore, with this technology, we can recover easily the CO2 that can be, because the residual methane can be separated in our plant. And thanks to that, we are, imagine that now the Regione Emilia is imposed for biogas from organic waste, the installation of a CO2 recovery also, which is, of course, a greenhouse, has a greenhouse effect, even if methane is 20 times more greenhouse effect. Therefore, in such a way, we totally reduce any emission of methane because we recover in the CO2 purification and we send back to the system. Therefore, we do not discharge any methane. This is what is happening in the huge plant in Montello, which is the largest in the world, actually. Now, there are other 60 units in a similar installation, which is a SESA company, SESA and Biomethan, that has each one a capacity, same capacity in total of Montello. It means 15,000 cubic meters per hour of biogas treated. That are the largest, but on 2 separate sites, not like in Montello, in the same plant. Therefore, we believe that even if in Morocco the first plant has been installed we have installed in Morocco just the first biogas plant, but based on membrane in a Delta Holding, in a company that was making sugar, and but they installed the biogas plant upgrading based on amine just to produce CO2, not to produce methane. That they sent to they have the biogas and they sent the biogas, the biomethane they sent to the boiler again. But we recover CO2 from their main production plus from purification of biogas. These are the applications that we are now. In addition, the quality of that we obtain on CO2, the quality that we obtain is absolutely food grade, complying with the ESBT, which is the guideline also for Coca-Cola. Is according to, of course, E290, which is the rule for Italian rule for food grade, and also halal. We have all has been approved for all the applications, the CO2 that we recover.
Mr. Hugo, you want to change the slide?
Come?
You want to change the slide?
Yes, of course. Go. This is just the application of biogas. Go. Yes. Yes. This is just our mainly on the brewery. Okay, go. CO2. Okay. These are only the breweries, in the breweries, where there is also biogas in the breweries, but we have not yet applied we're not yet convinced to recover biomethane from the biogas that is present in all the breweries. We have in InBev, in Gruppo Modelo, we have to just collecting and pre-purification, but not biomethane. Then we can change the slide, please. Again, go. Now this is, of course, the carbon cycle. And we expect that in a short time, we will have an excess of CO2 because of the distribution everywhere in Italy of the CO2 that is now concentrated in few industrial places in Ferrara, and most of the CO2 is produced is produced from wells. That is crazy. Therefore, what we tend to do now is to convince all the regions, and Toscana has already done, to close the wells, the natural wells, to recover CO2 and use the CO2 natural, but from the biogas. This will allow to avoid, because it seems strange, but 100,000 tons per year are extracted from underground in Italy for the market, only for the Italian market. And in Europe, there are several CO2 recovery plants from deep wells just to feed the market that can be absolutely satisfied by the biogas, by purification, as a byproduct of biomethane. CO2 can be recovered everywhere very easily. Of course, with the technology, with amine or potassium carbonate or membrane, can be easily recovered CO2 and close the absurdus recovery from underground. Then we can go. Of course, we will have an excess of CO2. Therefore, we will from the lack of CO2 now. Now, this is the solution that we were talking before. Now the CO2 emissions are still growing and growing. Of course, we will not solve the problem of the world, but anyway, closing the wells, we can imagine that just in Hungary, there is only one well that is extracting from underground 20 tons per hour of CO2. Only in Hungary, 20 tons per hour. That can be closed easily, leave it where it is, while carbon capture and storage has exactly the opposite of the purpose of the carbon capture. Now, then we can go. We are talking mostly about CO2. This is other. Now, what we do with all this CO2, there are so many applications because we have, these are one of the several applications. Several applications. One is dry ice in the United States is well used for cooling, also for fish cooling, and CO2 is freezing and also bacteriostatic. Therefore, is the best for conservation of at the low temperature the foods. The food. As liquid is cold energy. There are now growing the refrigeration system based on liquid CO2 instead of freon. This is another. Then as gas, greenhouse, for instance, we supplied also 3 CO2 recovery plants on biogas upgrading to one of our most important competitors using the same membrane. Therefore, we applied them, but we sold the CO2 also to this, all dedicated to greenhouse feeding. In Holland, there are so many greenhouses. They are producing tomatoes. Now more than some part of specialized in Italy. I don't know how is the taste. It's not like Italian taste, but anyway, is in this greenhouse with the CO2. You know that in the greenhouse the growing of vegetables is so strong. Therefore, this kind of CO2 anyways has been demonstrated with the publication, international publication, that can be used for any kind of application as the other CO2 best quality. Go again, microalgae, and then these are other extraction plant. We have an extraction plant. The CO2 is also used for desalination, for recarbonatation of desalted water, one of the applications, for instance, one of the salted water. This is Saudi Arabia, where there is no any source of CO2. Of course, no breweries, no. There are no distillation, no ethanol. Therefore, there is lack of CO2. Therefore, we burn something to produce CO2 that is necessary to recarbonate the water, the desalinated water. This is, and of course, for instance, it can be also the food waste can be a good source of methane. Of course, this country does not need methane, but need CO2. We have just sold to Puerto Rico an important plant that is producing biomethane, but the real necessity, but really they give more value to the CO2 recovery from the biogas. That seems absurd. Okay, go. Therefore, these are typically the picture of some of the system to upgrade PSA. Membrane upgrading, that seems more, let's say, all dry, is a dry system. Therefore, there is no liquid, there's no chemical aspect like PSA. There's no amine and water washing that are not so simple as it seems to be. Amine system in Italy is not agreed, but just because it's a chemical, while in the petrochemical is used to recover CO2 or to collect CO2 and to sweet the gas. But in this field, there is difficulty to apply amine as a technology, which that has the advantage to have a very good selectivity, and can separate perfectly without any waste, without any loss, CO2 and methane exactly in the two. This is a very high consolidated technology. Now, the technology of membrane, the advantage of membrane is just that is a new technology. This is why we look for that. And while the other technology has consolidated, there is nothing more to invent. And the optimization is practically impossible because amine there are new solvents, but more or less are the same as amine. All the other technology are consolidated, no improvement. In the membrane, since when we installed the first biogas plant based on amine, Montello, 4 or 5 years ago, other three, there was from the same Evonik, is 3 other generation of membrane has been produced. Therefore, the advantage of membrane is that is still improving. The price is decreased, the performance are increased, and still there is space to improve this technology. And this is why it's so successful, because now in the first plant we have installed more than 1,000 membranes. In Montello, in the extension is less than half with the same capacity and same performance. Therefore, still there is the next 6 months there will be another generation with a better performance again of membrane, while the other technology is nothing more, no more, it's consolidated. Therefore, we expect that the membrane system will decrease in price and increase in the performance. Therefore, will be more and more applicable. It will be the most successful application technology for biomethane. This is one of the package membrane, quite large. one of the 6 supplied to SESA. Now the membrane, one plant like this that has some year has half of the membrane that you can see in these pictures. Then go. This is the how is operating the membrane. The system is not a filter. It's like a filter, but it's not a filter. It's not a filter because it's based on a principle totally different than porosity. And this assures that there is no any possibility of virus or bacteria passing through the membrane and going to the CO2. This has been demonstrated because the membrane is a dense membrane, is not a porous membrane. We can go. This is how it looks like, each membrane. Membrane is really quite difficult in manufacturing, is a really high technology. It does not look like a high technology, but it's really a high technology, the fabrication. In fact, there are very few producers. Now this is just very simple. In the case of the biogas, more or less has the same components, except in the FORSU, but the type of components and impurities are always the same. The difference is the quantity of impurities that are present in each biomass. The worst is FORSU, is organic waste that has a lot of VOC, volatile organic compounds, and these are damaging the membranes, but are also damaging also the other, except the water, also the other technologies are damaged by VOC. Therefore, our experience is starts from the worst source, unfortunately, but allows us to set up exactly the technology. Now the H2S is present everywhere. VOC are mostly present in organic waste. Siloxane is mostly present in the landfill biogas. Now it means that the TPI has the possibility to treat the biogas and to make the complete chain. Now also the liquefaction. Therefore, we have upgrading with the separation of biomethane, CO2, make a CO2 food grade, and possibility to produce also LNG, of course, with purification over 99% of methane and the removal of the last CO2. Therefore, this is the diagram, the simplified diagram. This is a typical, the difference from organic waste is more rich in methane, while from agriculture more or less is 50-50. Okay, can go. This is from energy crops upgrading. This is a very little schema of the 3 stages that we use. 3 stage plus CO2 recovery, which is a typical CO2 recovery plant, same CO2 recovery plant, same technology that we use in the breweries or in the ethanol system or in other recovery plants. Very simple and very consolidated system. Okay, we can go. This is a picture of Montello, some of Montello plant, which is very impressive now. Is one of the 350-ton liquid CO2 storage tank and one of the first lines. You can see only 3 lines now. The first are 5 lines, the first plant, and now there are other 3 lines, each one 2,500 cubic meter per hour biogas treated. But in total, 15,000 that we believe for Evonik is the largest biogas plant based on membrane in the world. This is again the typical system, membrane. Let me say that membrane system is relatively simple because it's composed by pre-purification, which is very important, and just a system of 3-stage membrane that is really simple. What we found after 4 years experience in operation that are not so delicate as it seems to be. Let's say we were concerned in the beginning for the problem of membrane that seems delicate against oils. That is true. But at the end, we have not had till now, apart the pilot that we destroyed a couple of times. But now with the good pre-treatment, we have not had any problem after practically 3 years operation, 8,500 hours per year. In a Montello plant, we have not had any damage for the impurities. We installed a lot of, this is the system, very simplified. It means the biogas compressor that sent to the first stage membrane. From the first stage membrane, the permeate, which is CO2, goes to the third stage. It means that the CO2 is passing through 2 times membranes. Therefore, it's impossible that some bacteria can pass to the CO2. In fact, we did the test and the analysis on the bacteria, virus, others, organic, also on DNA for pork, because there was also a problem of qualification of CO2 for other application. And we found directly before the treatment in the proper CO2 recovery plant, before we analyzed the CO2, and was after the membrane was nearly part of the methane, residual methane that we remove in the strippers in the distillation, CO2 distillation system. We didn't find any trace of bacteria or virus or nothing else. Therefore, the CO2, in this case, even if the provenience can give some concern, is 99.99% pure. We have the analysis done by gas chromatograph and mass, according to all the rules, all the food grade rules, also Coca-Cola food. Okay. This is the solvent system. This is the other system that we can use, but it's not in Italy. We know very well, but we have only in industrial plant and only one plant in Morocco. That is a well-known system, is absolutely identical to a syngas system. Nevertheless, we saw that due to the aspect, let's say, the chemical is not agreed, let's say, in the farm. Something that is chemical is a washer with amine, and but we have absolutely the technology. And let me say that from the point of view of consumption, there is a thermal, here there is a thermal consumption, while in the membrane there is a electric power consumption. You have to evaluate what is available more. Okay. This is a typical purification liquefaction system. This is the schema that you can find exactly more or less identical in a brewery or in a fermentation, in other fermentation or recovery plant. Therefore, for us, the CO2 recovery is absolutely consolidated technology, nothing to invent. The advantage here is from the stripper of liquefaction, we can recover also the last methane, while in the brewery we recover the air that is possible there. In this case, we recover the methane that we put back there, for the loss is practically zero. Okay, can go. This is our in the last year, because we Italy started only in the last few years, and as you see, we have installed so many plants, and the number of cubic meter of biomethane produced by our plants are really a lot. If only SESA Group is producing 9,000 cubic meter per hour of biomethane, same 9,000, 10,000 because there is also one more, and also Montello next week on 27. Therefore, within end of end of the month, will produce again in total with the old and the new 9,000 cubic meter per hour of biomethane, and they will produce practically 220 tons per day of CO2, which will cover more or less 15% of the consumption, Italian consumption of CO2. That's changed the market of the gas also. Now, because the market in Italy is booming, but it will finish, we move again also in other countries, and in England we already installed some plants. In France we are starting. One is already installed, two under delivery. In Morocco there is one, but is an old one. In 2000 is from 2011, and now there are also one quite a large plant in the Netherlands. Two plants by 2,200 cubic meter per hour each plant. This is a new one plant that is while the membrane system was already existing. We installed this plant in an existing membrane plant to recover CO2 that is we sold to L'Air Liquide. The CO2 is sold to L'Air Liquide. Okay. All our plant from biogas are really food grade. This is the distribution of our plant. We have more than 600 installations around the world of CO2, because our company is 40 years old on CO2, while for membrane, for biogas, we have only 6 or 7 years, but we expect that we will reach these numbers in a short time. Okay, thank you. This is some picture, but okay. We realize in our workshop. Thank you. This is the picture of our factory in Brazil that I bought, and let's say I founded this company in the '97. And now we are the main producer of CO2 in Brazil. We think that we are the #1 in Brazil for the CO2. Okay, thank you.
Thank you very much, Hugo, for this presentation. It was excellent to know about your technology, membrane technology, the biggest plant of membrane of the world. And it was a huge company that have more knowledge that can share this information in Brazil. Have a huge market to improve. And next, we'll talk about the conversion of diesel of gasoline engine into a dual fuel CNG and LNG. Mr. Roberto Razio, from Ecomotive Solutions, Italy, specialized in natural gas and bio-natural gas, expert in application for the automotive and industry field, has a particular focus on bio-LNG and liquefaction technologies. Since 1998, works as business developer, a project manager for holding group. Is part of the board of directors of Consortium Biogas. He took speeches in several nations' international forums regarding the use of alternative fuels for the energy transitions. Please, Roberto.
Yuri, thank you very much. So greetings to all the audience, and of course to the other speakers. It was interesting to hear about their presentation. So now I am going to share my presentation. Hope to give you an overview about the final use of bio-natural gas. Well, our company and my role in the company, it is of course oriented to the final use of any alternative fuels. And during the years, we was able to enter deeper and deeper in the problem of using bio-natural gas. Let me say that the holding group, it is working on electronic controls of engines, and now it is also working on managing projects like liquefaction systems, and now we are also building parts of big gas turbine and so on. But anyway, the focus of our group, it is to final use of alternative fuels in this moment, especially ecomotive solution. It is working since 12 years with the most updated technologies to managing engines, both diesel engines, gasoline engines, and so on. And we are working with big names that are already there in the field of automotive or industrial. At the moment we have an open project with FPT, with CNH, New Holland, Kamaz, and Hitachi, and so on. Anyway, our rule, it is always to design solutions related to the engines. So the engines work, it is definitely our core business. Now, I wish to introduce you to one of the basement of our technologies that was there already 12 years ago, when in the world there was not so many companies who was speaking about the final use of natural gas on diesel engines. Because, you know, in the diesel engines, usually you can't burn natural gas, because natural gas has a really high level of ignition. So it means that in a diesel engines where you don't have a spark to ignite the combustion, you can't reach the temperature to the self-ignition of the mixture of air and natural gas. Because of that, usually instead of using a diesel engine, many companies are working with Otto cycle engines, so spark ignited. And this is really popular since a long time. The first application was on buses or on cogeneration systems that was using big engines with a spark inside, and so are like a big gasoline engine converted to natural gas. But our idea was to converting the existing fleets, big fleets of diesel engines that are there on the market, in something that was able to use in some way the natural gas as a fuel. So we decided to start the activity on studying the process of dual fuel. In a dual fuel engine, the gas and the air are mixed together in the inlet manifold. So the air and the gas are entering through the inlet manifold into the combustion chamber. So then, because the natural gas has a high level of ignition, the mixture resists for all the compression phase of the diesel. And nothing happened until the diesel will be injected. But then the electronic that we designed, that is an electronic platform able to control the quantity of diesel injected in an engine. This electronic decided to reduce dramatically the quantity of diesel injected. So what happened? The algorithm that is there inside of our ECUs are able in real time to calculate how much gas it is injected and how much diesel must be put off in order to keep constant the output of power, the output of energy of the engine. So this is a process that was designed and developed by our engineering department more than 12 years ago. And now we still working to the evolution of our technology. We are one of the only company in the world that is still working on a dual fuel, also on the most updated engine. So we are working on engines that are Euro 6 stage B, stage D, and we are still working to create the most updated solution for the environmental protection and also for the use of natural gas. Anyway, the field of application of dual fuel technology is really huge. You can see that any of the picture that you can see here are a field in which we already work with our technologies. And the advantage of having a diesel that use also natural gas, it is very nice, because with the diesel dual fuel, you can work both with this mixture of diesel and gas, or you can use the diesel as original vehicle. So in any market where the infrastructure of refueling of natural gas, it is not well developed or is ongoing, the use of dual fuel, it is really a very nice way to start up the market of natural gas in the transportation, because you can start with your tank full fill of natural gas, and then in case when you finish the gas, you are far from any service station, simply you can switch back to diesel, 100% diesel, without any problem of power or any problem of different style of driving. And you can finish your daily work without any trouble. So the main advantage in this technology is that it is not a mechanical technology. So we don't touch mechanically the engine. We are only adding injection system for natural gas. We are only adding a new ECU that works together with the original ECU in order to manage the energy inside of the engine and decide how much gas to put in and how much diesel to put off. So this is really a solution that is let the system to be reversible, so you can switch on and off. And in case you want to have your truck original, as for example in the end of the life of the truck, you can unmantle the system, and the truck, it is completely a standard diesel truck. But the benefits are bigger because when we speak about a substitution of huge quantities of diesel with natural gas, it means that you are speaking about strong reduction of CO2, first of all, because the emission of natural gas are definitely lower in the CO2 than the emission of diesel. And so a dual fuel system usually have a reduction, easily can reach a reduction of 10%, between 10 to 15% of the emission of CO2. But when you are using bio natural gas, this level, it is also higher, close to 50%. And this is also a system that give you the good feeling with the vehicle, because you don't lose any torque, any power, because this mixture, it is a dynamic mixture. The name of the technology is DGDI, and this name is diesel and gas dynamic injection. Dynamic because the computer on board, it is continuously changing the mixture between gas and air, and also the reducing the quantity of diesel according to the load of the engine. So in case of a strong load, sudden load, the system is able to change the percentage of diesel and gas in order to keep the performance constant all the time. And then, of course, we reduce also the noise in the engine, because the burning of natural gas reduce the noise than the burning of diesel. We get a better result in the oil quality, because the carbon that we put off from the diesel, it is not there in the natural gas, and so we can have cleaner oil in the engine. And then last but not least, usually the natural gas costs less than the diesel, and so you have a reduction of cost. And this is really important, because I always say that using dual fuel, it is one of the only time where the environmental protection don't cost, but give you a payback, and then give you also some money back every year that you are using this technology. So we are ready since the beginning to use any kind of natural gas. We can use compressed natural gas or liquid natural gas, cryogenic fuel, in the same way, because the system, it is able to manage both the two systems without problems. We are using usually on heavy duty trucks LNG more than CNG, because as you can see in this graph, the natural gas, 1 square cubic meter of natural gas, when it becomes CNG, so it is compressed in some cylinders, it is compressed at 220 bars, and it reduces its volume about 180 times. But when you are cooling down the gas, and you bring the gas below 162 degrees, and at atmospherical pressure, you can have a reduction of volume of 1 to 600. So it means that what was the volume of CNG cylinders, it is less than 2 times. So it is really a profitable way to store more energy on a truck or any vehicle. Since 2017 in Italy and in Europe in general, also dual fuel will be admitted to use LNG. And starting from that moment, you can see here a picture in a service station in the FAR 217, where you can see already how many vehicles, all these vehicles are vehicles that are using liquid natural gas as a fuel in Italy, and the major of them are with dedicated engines, are from OEM production like Iveco, Scania, and so on. And but there are also, like the first one with the dual fuel written on. There are also dual fuel systems that are using LNG as a fuel. Then we have to speak about our project together with the CIB consortium of Italian biogas producer about the using of biomethane as a fuel. The process of producing biomethane, it is now well known to you. So starting from feedstock or from any waste, you can organic waste, you can create a biogas, and then the biogas could be purified with upgrading system. And then our philosophy, it is to don't stop with the gaseous product, but convert the gaseous product into a liquid product, because the liquid product means to have a capability to have a logistic. So I can transport the liquid natural gas and I bring to a station everywhere, even the station is not connected to the grid. And so this reduced the dependence of the natural gas from the pipeline. And this is really great. And this is a good all for the on the side of the environment, but also on the side of the money, because this multiply the possibility. We start also considering the agriculture as a big potential for the conversion from diesel to dual fuel. You can see that we invent some solutions to store CNG on the vehicle. And this is some of our experiment. And this is an official project that we have with the CNH, with New Holland, to store more fuel on board. And this is a truck that we presented in Russia, because this will be produced from CNH in Russia. And we presented this last year in St. Petersburg Gas Forum. And this will be really a popular solution in the next future. We are also converting a vehicle to full gas. This is a system that produces the food for animals. And in the beginning, it was a diesel, but now we converted this diesel to full gas. So this is an Otto cycle engine, but we converted this in order to let the vehicle to use biomethane that is there in the farm that was producing this product. And this is one of the first producer of biomethane and liquid biomethane in Italy. And you can see that now this vehicle can run in the stable without making pollution, because it is running on bio-natural gas. This is another option that this is a telescopic system that can run only on compressed bio-natural gas, of course, in a farm that is already using this product as a fuel. And then already in the FAR 2015, we also tried to use LVG, so liquid natural gas by a biologic source on a tractor. And let me say, this is the next future that we are looking for. We love so much the use of LNG that we start also producing LNG with our own company, that the name of this company is 2LNG, and this company produces a small liquefaction system that can start from 2 tons up to 50 tons per day. And this is also one of the first company in Italy to produce some liters of LNG, and the project starts in 2015. And now it is we have a product that is ready for the market. It is a product that, thanks also to many cooperation, now will be one referral point for the liquefaction of biomethane. Some other projects we are following. For example, in Switzerland, we are converting such kind of small ferry This is the engine of this small ferry, and we are converting that to dual fuel to work with less pollution on the lake. Then we are working in the Lagoon of Venice. This is a project for DHL, and we converted this engine to work with natural gas, so with less pollution in the Lagoon of Venice. That is really sensible to emissions. And then, of course, this is a project that we are leading together with Hitachi and Trenitalia, that is the owner of the railway in Italy. We still have many old trains that are working with diesel, and so now we are converting the first one that will be an LNG gas train that works only with the LNG instead of diesel. So we are converting the engines, all the diesel engines, in 100% natural gas, and then this will be the first try that will be there in Italy, and to convert all the fleet of Trenitalia. Then we are also working in the harbors. This is a reach taker that works to move the containers, and in 2014 we already used LNG in dual fuel to convert this truck inside of a Green Crane project of the T10 EU project, and we got a really good results. And in the last years we was also in Germany in the Duisport, where we was able to design the same solution, but in a land port. And we analyze some results. You can see here that in black you have the diesel pollution, and in red the dual fuel pollution. You can see that there is always a benefit to use this mixture instead of using just diesel. Then we extended this technology also to the cranes. So this is another project. You can see that the installation of fuel tanks, LNG fuel tanks on the cranes. The first one in Italy, this one in India. And we are really happy because this application, it is growing. Now in South Africa, we are converting also big dumpers already to dual fuel. And in the next future, there will be a big fleet of dumpers also in India that it is growing. And so this is another project that will bring natural gas and hopefully bio-natural gas for special transportation. And so all these are example of systems that we already converted. And you can see here that there are many operations that we can achieve together with our solutions. We can, for example, work on existing fleets of trucks to convert this to dual fuel. We already worked, for example, in Santo Domingo for the fleet of Coca-Cola. This is with CNG. We are tier 1 with KAMAZ, with more than 2,000 converted trucks in Russia. Also for Iveco, we are working in Russia. Then we are working in Mexico on fleets of knabords. Then we are working in Slovenia for a big fleet of Mercedes LNG trucks. In Brazil, we already did some experiment with CNG. Bases in South Africa, bases also in Mexico. Now we are bases in Brazil, long-haul bases in Brazil, converted to natural gas. Then we are working for a municipality that needs small vehicles to have the rubbish movement, and then also with the sweepers and so on. All these vehicles I'm showing you are all vehicles converted to dual fuel with the use of natural gas. As of course, the same engine can work easily with the bio-natural gas, because natural gas and bio-natural gas in the terms of quality are exactly the same product for us. And we also had the challenge in 2018. We converted a pickup truck, and we was driven for 40,000 kilometers in 4 months. And we cross from Italy, we go to China, and we come back, all in dual fuel, and we was always able to refuel natural gas in the fuel tank. So this was a really fine challenge. And then, of course, as I told you, we also produce engines, full gas engines, starting from diesel-based block. For example, we are officially producer of a Zuzu engine, small engines that are employed for refrigerators systems. And then we are also working with the big engines for cogeneration system, all in dual fuel or dedicated with natural gas. So natural gas is a flexible solution. It is very fine when we use bio-natural gas instead, because of the pollution and the better results for the environmental protection. So I hope that this technology we designed and developed many years ago still be interesting, especially in market where the business of bio-natural gas is starting right now. And so we hope to come back soon to Brazil and to have a new adventure. And so thank you very much.
Thank you very much, Roberto, for this great presentation. It's good news to know how can you use biomethane, the vehicles, and have a huge experience with a lot of ways of transport, trains and
everything.
Trucks. That's awesome. And from next, we have two debaters. And next, if you are hearers, you can send some questions. We have 20 minutes at the end to give the answers. And now I want to talk about the obstacles to the development of biogas in circular economy in the context in Africa. Professor Dr. Hassan El-Bari, he's a Ph.D in Material Science, Renewable Energy and Environment Laboratory, ABREN, Tufayl University, Kenitra, Morocco, President of Moroccan Association of Solid Waste. Please, Hassan, have the word. You have to open your microphone, the button. Not yet.
Okay.
Yes.
That's
okay.
It's okay now.
Yes.
I have to share the screen?
Yes.
Okay.
The green button.
Okay. Is it okay? Is it okay?
You can start the presentation.
Okay.
Full screen, yes.
Yes. I will talk today about some main obstacles to develop biogas in technology in Africa, and in which condition we can do it in circular economy context. The content will be the circular economy approaches, objectives, biogas industry in circular economy context, and main obstacle to overcome the biogas promotion. As you know, biogas technology can contribute to 9 points in sustainable development goals. We can see zero hungers, good health, gender equality, clean water, climate actions, and so on. So it's very important to use biogas technology in climate change context and environmental protection. In order to achieve the objective of circular economy, it's essential for biogas plant to be able to close the loop in the integrate anaerobic digestion process. This can only be achieved by a suitable treatment of digestate that allows a sustainable and economically viable recycling of digestate. It's well known that the most frequent use of digestate is its application as agriculture biofertilizer, allowing the soil to be enriched with micronutrients such as nitrogen, potassium, and phosphorus. However, this operation is not always real and cost-effective, as it depends on many conditions, such as economic feasibility of or the composition of the state, which it could not be suitable for the agricultural soil around the biogas plant. In this case, alternative solution to the state recovery must be considered. In this context, there are several systems that can solve this problem. These systems combine biochemical and thermochemical conversion of the biomass if the calorific value of the digestate is not too low. This is the case of most lignocellulosic biomasses, where the rate of biodegradability of the substrate in aerobic digestion is not very high. Some examples of bioenergy technology could use in combining form to achieve the to close the book and achieve the circular economy objective. You can see gasification, pyrolysis combined with anaerobic digestion to produce heat, electricity, and fuel. An example of coupling and combining this thermochemical and biochemical biomass conversion. You can see here when we produce the biogas for cleaning up garden, CO2 and methane, we can make separation of digestate in liquid and solid fraction. The liquid one could be used with alga product for water treatment, and we can, for the solid fraction, we can combine pyrolysis or gasification to produce syngas. This is a way to close the loop in order to achieve the circular economy objective. This is an example of our pilot plant in our laboratory, University of Tofel. It's a USB digester, biogas flow meter, used for biogas production from recycled paper wastewater influent, coupled with solar energy. We try to heat the digester with solar energy, and we have integrate micro cogeneration system to use the biogas purified. This is some publications of our research team about this system, to couple solar energy and biomass. Let us see the role of anaerobic digestion and biogas in circular economy. In the future, bioeconomy waste will be transformed to the high-value products and chemical building blocks, fuel, power, and heating. Biogas facility will play a vital role in this development and the implementation of novel production paths that arise in the transition to the bioeconomy. The flexibility of anaerobic digestion system and its ability to digest a multitude of organic feedstocks while producing a significant range of products ensure the role of AD and biogas in the circular economy. There are three circular economy areas which are linked: waste management, consumer demand behavior, and supply from economic stakeholders. The current concerns of scientists is the basis of the circular economy and the optimization of the value of material flows. Circular economy can only be achieved if all material flows in a whole value chain are considered. The material circularity indicator, it's used to estimate the degree of material flow restoration of a product and as decision support tool for designers. There are three circular business model categories at different value chain steps: design and manufacturing phase, use phase, and value recovery phase. It's crucial to integrate all suitable energy to waste technologies in the waste management system to achieve circular economy objectives. Policymakers and public can be made more aware of the importance of circular economy through different life cycle approaches, such as LCA and others. The achievement of circular economy objectives through sustainable biogas recovery will be done through different combining systems, such as coupling anaerobic digestion with gasification for enhancing energy and material recovery, combining anaerobic digestion with gasification for electricity and biochar recovery, and concept of using AD and hydrothermal carbonization, integrated anaerobic digestion and pyrolysis. Let us see now what is the main obstacles to develop biogas technology in Africa or to overcome. In order to promote biogas technology in a given country or region, it's necessary to be aware of the main obstacles that hinder the development of biogas as renewable energy source. What are the types of obstacles and barriers that can be considered? Well, we can summarize in 6 obstacles types. First, technical obstacles, then economic obstacles, market obstacles, institutional obstacles, socio-cultural obstacles, and environmental obstacles. In this institutional obstacles, the most significant institutional obstacle is lack of biogas national program. Significant government support for biogas industry is therefore necessary and very useful. Concerning the technical obstacles, these technical obstacles generally depends on the degree of development of the country. Lack of adequate local technology suitable, lack of qualified local technical competence, economical obstacles. We can see biogas production units are characterized by very high initial investment. Biogas used as biofuel to purification processes into biomethane need also high investment. The unavailability of government subsidies and low interest rate bank loans. There are only few bank loans opportunity. The growth rate of different African countries depend on the level of availability. Thus, there is variable economic growth in the biogas market in the Middle East and Africa. Concerning the market obstacles, the price of biogas produced exceeds significantly the whole price. Biogas needs to be competitive in terms of price compared to other fuels. However, the use of biomethane as fuel or its injection into natural gas grade could overcome these price obstacles. We still need subsidies like Europa countries. Environmental obstacles, the main environmental obstacles is certainly the large amount of water needed for the anaerobic digestion processes, especially in case of water scarcity and during the summer period. Other minor environmental problems might exist, such as noise pollution or other problems from biogas plant. Finally, the social cultural obstacles, low citizen participation, lack of consumer interest is the main socio-cultural obstacles. Social and cultural factors are not taken into account in the system design. Lack of effective communication with potential biogas users about the benefit of appropriate use and awareness of biotechnology. So for Africa, opportunity concerning biogas technology, it could contribute mainly to reduce pollution, to increase life expectancy, reduce firewood collection, increase literacy, create new jobs, increase food production, and improve public health in rural area. Thank you very much.
Thank you, Hassan, for your presentation. Morocco and Brazil have some of the same problems. I agree with you. The institutional issue is the biggest obstacle. It's in the international literature, the World Bank as well, because institutional have to change the minds of the people that are working. Sometimes you have laws, you have technology, you have money, but you have the problems about the institutional. And I agree with you. Thank you very much, Hassan. And now I want to call from Suani Coelho to be the next debater. The Ph.D. Suani Teixeira Coelho is master and Ph.D. in bioenergy at IEE USP, professor of the postgraduate program in energy at IEE USP, and the doctoral program in bioenergy at ESAERT USP, project coordinator, the prospects for biogas and biomethane for the state of São Paulo, and assistant secretary of environment of the state of São Paulo from 2003 to 2006. Dr. Suani will talk about biogas and biomethane in Brazil. Please, Dr. Suani.
Thank you, Yuri. You did a long list. Okay, let me share my screen. Okay. So as Yuri said, I am professor at the University of São Paulo, and also University of São Paulo, for those who doesn't know, is the largest and the first university in Brazil. Is a state-owned university, not a federal, a state university. And I also work at the Research Center for Gas Innovation, which is a new research center funded by FAPESP and Shell Company. It's a very large research center with around 50 new projects and 300 researchers. And we are one of these groups working there. So the idea, I saw the presentation from colleagues from Italy, and then I put together a few experiences that we have in Brazil, so we could also give the Brazilian experience in this area of biogas and biomethane. In fact, this is something in very early stages. We had around a little more than 100 megawatts installed with electricity from biogas, mainly landfills. The most used is the electricity generation. This is not too much. The total installed power in Brazil is more than 1,000 times bigger. And only biomass in the electric matrix is 15 gigawatts. So around 100 megawatts is not that much. But anyhow, it's something that is increasing, and perspectives are very important. We have some figures from Biogás, the Brazilian Association of Biogas and Biomethane, showing that we have large potentials, mainly using biogas from sugar ethanol plants. And I'm going to give a little, some examples on that already existing in the state of São Paulo. Well, as I said, most of biogas in Brazil is used for electricity. We have here the largest thermoelectric power plant in the state of São Paulo, Termoverde Caieiras, with almost 30 megawatts. And this is, for us, this is a very interesting project, not only because it's the largest one in Brazil, but because we have been very much involved with them in the early stage. Like almost 15 years ago, we developed together with them a small plant of only 200 kilowatts using biogas from the landfills. It was a project funded by the federal government. And Calheiras was the landfill who accepted us to install and develop this project. And then we realized that they liked very much the results, because later on they decided to improve it. And from the 200 kilowatt project, now we have a 30 megawatt project. So it's a very important project in the country. We have also considered, when we have a look on landfills, we have this biomethane plant in Ceará, Fortaleza, which is the largest biomethane plant in the country, with 85,000 cubic meters per day of biomethane being produced. In fact, when I visited, it was that. Now I know it's almost 90,000 cubic meters. And they sold it to the gas company of Ceará, and they sell it by a price with a premium of 30% higher than the natural gas the Segás buys from Petrobras. So Segás buys a lot of natural gas from Petrobras, but they also buy all this biomethane from the landfill with this 30% price higher as a premium for being a renewable gas. And the process that they use for the biogas upgrade is a PSA, which they consider, when I visited and I discussed it with them, they consider that it was very interesting. They are very satisfied with it, even consider a large scale project. Okay, going for the other sector, we have here a brief overview of the sugarcane ethanol. And the main challenges that we have in this sector is not only that it's only produced during the season of ethanol production, but also the large scale of the plants. So this is, in the previous slides I sent to Yuri, these figures were not there because these figures I cannot put at the internet, but I can show you because Bonfim Mill allowed me to show you. So with permission from Bonfim. Bonfim Mill is one of the large mills belonging to Raizen Group, and they are developing now a project of biogas for 20 megawatts to be installed in the mill using vinasse from the ethanol production together with other residues. As you know, in Brazil, most of every ethanol production mill uses vinasse for irrigation and fertilization of the sugarcane field. But we can also produce the biogas from vinasse and couple this with the irrigation as well. We had a long story of vinasse biogas for the last more than 20 years with failures and good projects and good results. And now I'm going to show you a couple of projects that we have with good results. So here then we have this mill, Bonfim Mill, is a very large, like almost 5 million tons of cane crushed last season, and almost 170 million liters of ethanol, and producing 65 million cubic meters of biogas per year. This corresponds around 300,000 of cubic meters per day. So if the Caucaia landfill produced 90, here we have 3 times the Caucaia landfill plant. So it's a huge plant. The idea is to produce during the season using vinasse and filter cake, which is a byproduct from the ethanol production, and off season, when we do not have vinasse because we do not have the ethanol production, but we can store the filter cake and use it. Then we still have a production, a smaller, of course, but we still have production of biogas. This is the same process used by Geoenergética, patented by Geoenergética in Paraná state, which is a very efficient process developed by them, using not only vinasse, but using also the other residues. We have also a new plant using the same technology to get developed by Geoenergética and installed to being developed here at Cocal Mill, also in the state of São Paulo. They crush, again, 5 million tons per year. It's a very large mill. And the idea is to use filter cake, straw, and vinasse in the biodigestion plant. But in this case, the biogas used part for electricity production to be sold to the market, but also to have part of it to be upgraded and to produce biomethane following the standards from the regulatory agency, and to be used in a dedicated pipeline. Here you have the map of São Paulo state, where you can see the dedicated pipeline to be built. It's an agreement of Cocal Mill with the Gás Brasiliano, which is a natural gas distributor in São Paulo, and also to use part of it in the mill, in tractors. Here you can see tractors developed by Scania and being already tested with biomethane. So this is one of the more recent projects that we have in the state of São Paulo. But we have still a very large potential, as we have assessed in the research project that we developed in FCGI. So here you have the link. I'm not going to spend too much time on that, but here you have, it's an iterative mapping of the state of São Paulo. It's free for download. Then you can interact. You can touch the municipality, and then you can select the source if you want urban residues or animal residues or sugarcane sector. And then you can see in each municipality what is the potential for biogas, for biomethane, or for electricity. And the results obtained are impressive, very huge amounts that we could use for different purposes. The most important is that in some areas where we do not have the pipelines to inject in the grid, we can use for local dedicated fleet in the municipalities, as in the case of Cocal Mill. And this is an experience that I consider very interesting, because we can replicate it in other areas of Brazil. In the Center-West, for instance, where we do not have distribution of natural gas, we could use the local biomethane produced from animal residues or rural, urban, doesn't matter resources, and to distribute it with dedicated pipelines. So you have the link. You can download the maps and to interact and to play as you want to get the results. In fact, if we compare, for instance, just for the Ribeirão Preto region, which is the most important region of sugarcane in São Paulo state, and if we compare the amount of biogas produced only from vinasse, without using filter cake or straw, we can have important production compared with the consumption of municipalities. Here you see, for instance, that in Sertãozinho, which is a very important municipality and very large, we could produce around half of the total amount of fossil fuels used. Or, for instance, in Barrinha, which is a small municipality, but with a large potential, we could have much more biomethane being produced than the amount consumed in the municipality. So with an important option to be exported. So here you have just to illustrate a comparison of the potential in each municipality with the consumption. This was part of the PhD thesis of one of my students, Manuel Poveda, last year. And of course, we can couple all this with the carbon balance and with the perspective of do the carbon capture in ethanol plants. It was mentioned by Hugo. I loved your presentation. I loved the picture that you showed capturing CO2 from atmosphere. If you allow me, I'm going to use it in my classes. But anyhow, in the case of Brazilian ethanol, as you know, we do not have any fossil fuel in the industrial plant because all the boilers are fed with sugarcane bagasse. So if we are able to capture the carbon from the flue gas, from the fermentation, and also from the biogas upgraded, we could have important perspectives for a better carbon balance. And even if we do this bioenergy together with carbon capture and storage or carbon capture and use, as was mentioned by you before, we could have an important reduction on the carbon footprint of Brazilian ethanol. And these are subjects of a new project that we are developing and preparing now in the Research Center for Gas Innovation, including the relation of this process of carbon capture in ethanol plants with the Renova Bio program. As you probably are aware, Renova Bio program is a new program of carbon credits approved by federal government and already in place, where the distributors of gasoline and other fossil fuels have to buy carbon credits from biofuels producers, bioethanol, biogas, biodiesel, to reduce their carbon footprint. Now, the target defined by the Council of Energy Policy is a reduction of 10% in the distributions matrix. So they must buy the carbon credits related to this. And so the idea is in one of these projects is to see how the impact of this bioenergy and carbon capture in this Renova Bio program. So we have been working a lot during these last years in this project that I showed you, but we still have a lot of work to do, even because the challenges are still very high. Here you have the links for the RCGI, for our research group at the Institute of Energy and Environment, and my personal email, and I am available to answer any questions. It would be my pleasure. I hope I did not talk too much. Yuri said I had only 10 minutes and I always talk too much, but I hope I could do it. Thank you very much for the opportunity.
We had a good event. I have 7 questions. It was very fast. If the speakers can be fast to give the answers, no problem. Not so difficult, and you can say that we have big.
I don't see the pictures, the questions here. You are going to let us know.
Yes, now, yes. I have the first question.
I have one question, please, for Mr. Ugo Moretti.
Yes, you can ask Hassan, please.
Yes, about subsidies prices of biogas in Italy. How about the subsidies price, the price of biogas?
Not of biogas, of biomethane,
is there any help of your government?
Yes, a lot.
And this help is increase or decrease with the time?
Oh, now is as before. Is quite new. Therefore, the incentive for biomethane, of course, is still is quite new. Therefore, they cannot change now.
Yes, but
That was explained by Lorenzo in the beginning.
Yes.
Yes.
But the regulation will
incentive.
finish by 2 years. By 2 years, this regulation will
by
finish.
2 years is electrical.
Electrical.
Will finish. Instead of electrical, this is the reason why most of the companies moves from electrical to biomethane, which is incentivized a lot as well.
Please,
I have one question as well. I understood from the presentation from Hugo that you have a plant in São Paulo, in Salto.
So we have the companies in Salto. We start in San Bernardo, and then we moved some year ago, 3 or 4 years ago, in Salto.
And what do you produce there? Do you produce technologies for carbon capture?
Yes, completely, yes.
Okay, okay.
But we have many plants in Brazil, so many. All the breweries, more or less.
Okay, always related to
has, some 10 or 12 plants. Petropolis, King Cariol, Kaiser, everybody has our plants.
Okay, congratulations. Thank you.
Now we are working on with the ethanol plant, and we are dealing for. We are trying to get to make because from ethanol is not so different. The capture of CO2 is very important in the ethanol plant.
Yes.
In Pakistan, where there is no other source of CO2 and ethanol is just for other purpose, of course, not for drinking or not for. Yes. We have 6 or 7 CO2 recovery plants from ethanol. But in Morocco is also from.
And if you recover from
Kenitra, he has to know.
Kenitra, yes, I know the Sotramek.
Sotramek, exactly.
Yes, but there is problem with venous pollution. The limit of chemical oxygen demand. We reduce it, but we cannot achieve the reglementation because the initial is 50,000 milligram per liter.
I don't know. Because we installed the CO2 recovery plant in the beginning, and then we install a upgrading plant to increase the production of the production of CO2 that was destined to Air Liquide.
Hugo, I have a question to you.
But we have so many other plants in Morocco, in Maghreb Oxygen.
Can you send me the link after, please? Link.
Maghreb Oxygen, we have several plants.
Okay.
That's nice. Hugo, I have a question for you. Luis Sergio de Carvalho asks, this membrane can be possible to substitute by graphene?
We don't know, because actually they can be graphene is under study, but this is our polymeric membranes, because there are several types of membrane. There are also carbon, pure carbon membrane. There is a company, Israeli company, that was carbon membrane. We tested and it was perfect carbon. Therefore, I suppose that graphene can be even better, but depend from what you have to separate. For gas, it's not the same as because membrane is confused as a filter, is a fine filter. It's not exactly the same thing. For gas, the membrane are totally different than from liquid or from. There are also zeolitic membrane, MOF-based membranes. There are so many type of membrane. Has to be selected according to the purpose. Graphene is an absolutely new material, therefore not yet developed.
Thank you, Hugo. Another question for you, Hugo. What's the lifetime for the membranes, and what about the CapEx and OpEx?
OpEx is really, it was supposed quite high, but really now we understood that is relatively low. we start with the idea that 10% of membrane per year, according to the producer, has to be changed, or let's say there was a degradation. Really, there was not experience at that time. Really, after 4 or 5 years operation, there is no any degradation. We make analysis. Therefore, unless there is an accident, means a carryover of water or pollution or VOC or mechanical damage, that is quite difficult. We have a real low OPEX, apart energy, power consumption. But in terms of degradation of membrane is more reduced than in the past. Let's say that membrane life can be for sure more than 10 years. But for membrane are decreasing. Actually, the CapEx is decreased and therefore is very similar to all the other technologies. Not so different. We see that PSA cost now that was lower, now is more or less similar. Water washing is even higher. Amine system is more or less the same in terms of CapEx. OPEX, actually the problem of membrane is the power consumption, because there is a 0.3 kilowatt more or less per cubic meter of biogas treated. 0.3 kilowatt. This is the OPEX. For the maintenance is very poor. There is nothing.
Thank you very much, Hugo. Another question. 1 meter cubic of biomethane is capable to replace what liter of diesel?
Cubic meter is 0.7. Therefore, if we speak about kilograms, is a different story.
Okay, when we are speaking about the comparison with diesel,
kilos with kilos.
Yeah, because we know that in Brazil the selling it is for a square cubic meters. So when you buy 1 square cubic meters, practically you have the same energy of a liter of diesel. More or less. If we are speaking in Europe, where we are selling in kilograms, 1 kilograms of natural gas, it is close to 1.4 liters of diesel. But in square cubic meters, 1 square cubic meters is almost 1 liter of diesel, equivalent in energy.
Thank you very much, Roberto. And the last question, Sergio Carvalho asking, possible to capture the CO2 generated during saccharose fermentation during ethanol production?
No, during ethanol production is CO2 is usually captured, like in the beer.
Fruits. It's the low-hanging fruits. The easiest one to capture, the cleanest one, and the easiest to capture.
Oh, yeah, easiest, but it's not the cleanest, because the level of impurities that are allowed in the food grade CO2 is the level of ppb, no more ppm. The total sulfur is 0.1 ppm, means 100 ppb only. Therefore, the CO2 food grade must be very, very pure. Huh?
But if you compare with, for instance, CO2 in exhaust gas from the boiler.
Yes, of course.
That's why I'm saying.
From flue gas. But imagine that in Arab countries, we capture CO2 from flue gas, where the CO2 is 10%. Therefore, the capture is absurdus. And nevertheless, there is no other way.
We can use also
in Morocco, let me say that we have 2 plants. We have 2 plants from combustion. Therefore, to produce CO2, we burn propane. That is absurdus. But then, nevertheless, we have 2 plants. And in Morocco, the CO2 is imported for local consumption. It's important from Spain.
For drink.
For drink is important. CO2 is not sufficient, the production in Morocco. And we have 2 combustion plants. Therefore, we burn something to produce CO2 in Morocco.
I have one question.
Yes.
here in Brazil, at least the plants that I have been visiting and studying, they use PSA for the upgrade of biogas to produce biomethane. And I saw you talking a lot about membranes. And but in the case of the sugar ethanol plants, as you could see, the size is very, very high. We have thousands of cubic meters per hour. So people are wondering about using PSA as well as in the. What is your comments on that?
PSA is, in my opinion, now is suitable or is overpassed by membrane and by amine, and is suitable only when there is a lot of nitrogen, because membrane cannot separate nitrogen from methane. Therefore, is absolutely a good technology for landfill biogas. But for the other application, is actually out of, let's say, membrane is more, actually membrane and amine are more suitable, are more selective, and there's less pure gas. Less off gas is without any methane, while PSA you cannot avoid methane in the off gas, and you cannot recover CO2 from the off gas of PSA system. But of course you can use only PSA in the biogas from landfill, because the nitrogen content is so high that you cannot obtain a good methane unless you use, and it's not possible actually with the membrane. We are studying a new membrane that can separate an additional step of membrane, but actually the PSA is the only technology for landfill.
I have a final question for Lorenzo. Lorenzo, what kind of recommendation you can say to Brazilian government to improve biogas and biomethane? What kind of recommendation? As you told us, have some subsidies, 1 billion euros per year in Italy to increase to become the second country in the world of biomethane biogas production.
It's not a very simple question, Yuri. I prefer a technical question. This is a more political question. But yes, from my point of view, just to push the market at the beginning, you need subsidies. So a good idea is to do something similar to what happened in the past, in not only in Italy but also in other European countries, like in Germany, or as it is happening in France. So every country has developed a different way to push the market of biogas for renewable electric energy, or the market of biomethane. In the past, we received really high subsidies for electricity, 0.28 euros per kilowatt hour for 15 years. After they decided to decrease, but to have more years, so we received 0.23 for the newest plant, 0.23 euro per kilowatt hour for 20 years. For the biomethane, now we receive. Yes, I have explained it, but probably is more easy to talk about euro per cubic meter. We receive around 0.6 euro per cubic meter of biomethane, and we have to show that we use biomethane in the transport sector. It allows us to reduce a lot the big problem of pollution of the air. So this could be really a good idea for your country, to push the use of biogas and biomethane in the transport sector, because I think in every country of the world we have a problem of pollution. Diesel cars and gasoline cars have a high emission of carbon dioxide and also of other gases. Using natural gas vehicles or using biomethane vehicles is really possible to reduce a lot of the pollution to reduce a lot the carbon dioxide emission. And to do it in Brazil, you need public subsidies. So this is my suggestion. Ask to your government to help you to develop this new market, giving you subsidies for the production.
Yes, thank you, Lorenzo.
You're welcome.
It's a good recommendation. And I would have to thank you for everyone. I will give it 1 minute to everyone to the final considerations, and we can finish the event. Hugo, you can start, please. 1 minute.
We
have 1 minute to the final considerations. To which one? We have 1 minute, please.
What I can say. I've just explained maybe our opinion, but mostly regarding CO2, but really the argument was more in the biomethane, but is related on the CO2 is for us is our core business, was our core business, now is biomethane. Brazil has a great potential, and we want to enter in the market of Brazil. Hope that, anyway, you can contact me. In any case, you have my reference for any question, technical question. I have quite 40 years experience on that. I can give some support. Thank you.
Thank you, Hugo, very much. Mr. Lorenzo?
Well, let me say, let me say first of all, it was amazing to stay with you and to hear the other speakers. And I believe that for Brazil, it is a big opportunity to start using bio-natural gas. Bio-natural gas, it is the only way to be really carbon negative. So it means that by doing something good for the health of the soil, the health of our world, we can also reduce the pollution in the air. We can also give better results for also for the economy, because we can reduce the dependence from, let me say, fossil fuel. And so really, this is a moment with a big opportunity and the big potential that is there in Brazil. I believe it is something that must be taken in consideration from all of the politicians and also all the entrepreneur that wants to start up this activity. So go ahead and we will follow you.
Thank you very much. Mr. Lorenzo, can you say the final considerations? 1 minute.
Okay, I just want to thank you again for the invitation, to thanks all the speakers, really interesting presentation. Obviously, to thanks all the people that decided to spend time following this YouTube WtERT. And I really hope, Yuri, that between the Italian Biogas Association and ABREN, we can increase our collaboration. From my point of view, is really important for both the countries. We can have and you can have advantages. So when it will be possible, I invite you to come in Italy to visit our new biogas and biomethane plants. Not only you, Yuri, also other speaker. And obviously, I will be really happy to come again in your country with an Italian delegation in order to discuss about potential partnership.
Thank you, Lorenzo, very much. And you can have an agreement to cooperation with Italian Biogas. Next year, you can make an event to call to all the speakers to participate and to discuss more about biogas and biomethane. And now, please, Mr. Hassan, give your final considerations. You have to open your microphone, please. It's on boot.
Thank you very much for this very important webinar with high quality presentation. I think that the future is the biogas. mainly, I would like to focus on Africa potential. Africa potential in biomass is very big, and Morocco could be the introduction to African market, because we are close to the Europa, and our level of development, it is between European countries and South African countries. So we can be sort of intermediate to contribute to the development of this technology in many Africa, mainly in Francophone Africa, for example. There is no barrier language, for example, because in Morocco we speak French and Arabic, of course. So Francophone countries is very easy to have the market, and just to consider the socio-cultural situation of these countries when you propose solution, because technology should be suitable, appropriate to the African organic waste and to cultural, socio-cultural situation. So we are quite open to develop cooperation and feasibility study. Our association is very open to help and contribute to the achievement of a technico-economical study of the possibility for investment in biogas, organic waste to biogas, and to other.
Thank you, Hassan, very much. Dr. Ani, please, final considerations.
Okay, no, it was a pleasure to be here with such an important group of researchers and entrepreneurs. And just to say that at the Research Center for Gas Innovation, we have been working hard with all these issues, not only in technology. We have lots of colleagues from engineering school, polytechnical school, working with new technologies and advanced the process, but also in the area of policies and economic analysis, trying to push the governments to increase the use of biogas and biomethane in the country. I hope I can have good news for you in the near future from the governments. Hope so. Thank you very much.
Thank you everyone for the event. You are assisting us. ABREN is an association that works with waste to energy, biogas, biomethane, with animal and vegetables or urban waste. And it's our job to create all the conditions to develop the market. And if you have some questions, send an email to us. It's abren@abren.org.com, or you can visit our website, abren.org.com. Thank you very much. Have a good night for the Italians and good afternoon for the Brazilians. Thank you very much.
Okay, bye.
Okay, ciao.
Thank you.
Grazie. Ciao a tutti.
Ciao.